All right, it looks like the attendee numbers have stabilized. Everyone's here who's going to be. Let's get started. Welcome. This is the Science and Values in Climate Risk Management webinar series. I'm Casey Helgeson from the Earth and Environmental Systems Institute here at Penn State. I'm one of the co-organizers of the webinar series, along with Nancy Tuana in philosophy, Klaus Keller in geosciences, and Rob Nicholas also in the Earth and Environmental Systems Institute. And we do this webinar series with support from Penn State's Rock Ethics Institute and Center for Climate Risk Management. So I'm just going to give you a few instructions about how to participate in the webinar. Then I'll introduce our speaker and hand over the floor. Professor Parker will talk for around 40 minutes. Then there'll be time for Q&A and we'll end at 5 o'clock. Or for those in other time zones, 1 hour from now. So to participate, you can do one of two things. When the time comes for the Q&A, you can use the raise hand function, and then I will enable your mic and you can speak your question. That's the preferred method if you're willing, just to make the proceedings a bit more lifelike. But if you prefer not to talk, you can also put your question into the chat. We are recording this, by the way. You can put stuff into chat at any time during the talk, and then when we get to the Q&A, I'll read questions from there. So our speaker today is Wendy Parker. She is a professor of philosophy at Virginia Tech and previously a professor in the philosophy departments at Durham University in the UK and Ohio University. She did her PhD in the history and philosophy of science at the University of Pittsburgh. And she holds bachelor's degrees in both philosophy and meteorology. Her research addresses how simulation models are used in scientific practice, how these models should be evaluated, how uncertainty should be represented and communicated, and also the roles of values in scientific practice, which will be the topic today. A few other of her activities. She is a co-editor-in-chief of the British Journal for Philosophy of Science. She's a contributing author for Working Group 1 of the 6th Assessment Report of the IPCC. And she's a member of the Working Group on Ocean Uncertainty Quantification within the US Climate Variability and Predictability Program, CLEVAR. Professor Parker, welcome. Thanks for being here.
Thanks very much. Just during your introduction, my internet started having a problem, so I moved. I apologize. If there are any more problems, please let me know. I'm going to do my best.
Will do.
And thank you very much for having me here today. Just going to share my screen now. Okay, so today I want to be talking about values in science, and I just want to emphasize that this is very much a work in progress. I'm in the middle of writing this paper up right now, so I'm very, very eager to have critical feedback and suggestions for things I need to look out for when I'm trying to develop my arguments. So I welcome your feedback. So the question I want to focus on today is one that may be familiar to many of you. It's the question of how what are often called non-epistemic values, social, ethical, political values, how these should or shouldn't influence scientific research. So my aims today are going to be twofold. First, I'm going to try to intervene in a sort of ongoing philosophical debate over the answer to this question. And second, I'm going to try to offer what I hope is a useful way for scientists to think about non-epistemic value influence. So I'm going to be doing one thing, but I hope it's going to accomplish both of those aims. Now, just a quick note on values. So the whole distinction between non-epistemic and epistemic values is a contentious one, and we could spend quite a lot of time just trying to carefully sort that out. I'm not going to do that today. If you want to talk about that distinction, please feel free to raise that in the Q&A. I'm just going to rely on you to go with the distinction for now. So if you're not familiar with these terms, you can think of non-epistemic values as things that we value for reasons that are unrelated to gathering knowledge. So things like social justice, health, wealth, environmental sustainability. These are things that we sort of attach positive significance to. We can contrast those with what are often called epistemic values, things that we value for their relation to knowledge gathering or truth. So we might think that truth is an epistemic value, understanding. If we're thinking about theories, we might think about their being internally consistent or having explanatory power. So the question we're interested today is what role things like social justice, health, wealth, those kinds of values, how should those values influence scientific research? So the sort of common sense, I guess, traditional way of thinking about how, the sort of common sense answer to the question of how non-epistemic values should play a role in science is, the influence should be very limited. So here's one statement of what's sometimes called the value-free ideal. It says, as much as possible, the internal research stage of investigation should be kept free from the influence of these kinds of values, these social, political, and other non-epistemic values. Now, just to be clear, what do we mean by this internal research stage? We'll say more about this in a second, but the kinds of activities that people have in mind when they defend the value-free ideal are things like performing experiments, analyzing data, developing mathematical models, reaching conclusions in light of data. These are the activities in the internal research stage that people argue should be kept free from the influence of non-epistemic values. You can contrast that, and sometimes it's helpful to have this clearly very oversimplified picture, but sometimes it's helpful to understand the value-free ideal using an image like this one, where we sort of imagine some different stages of scientific investigation, where in the maybe what we might call the pre-research stage, we're sort of choosing our topics, the questions we want to answer. Then once we have those, we might start to carry out the research, right? Perform the experiments, build the models, see what the data support, reach some conclusions. That's all in the internal or research stage, the sort of stage where there's the most debate about what value influence should be like. And then we might also think about a post-research stage where maybe we've learned something and now we're going to develop some applications of it, or we're going to communicate the results widely. So when people are discussing the value-free ideal, they're often very comfortable with values playing a role in where the green boxes are. So the argument might, so someone might say, look, it's fine for you to choose a research topic because you think that it's important to society, right? That's not a problem. Or it's fine for you to decide not to pursue a particular technological application because you think that it could be used harmfully. So there's no problem with non-epistemic values having some roles to play in these green boxes that we might argue about exactly how it should happen. The action in the debate is usually over whether these kinds of values should play a role in that internal research stage. Okay, and so there is one kind of influence there that most people are happy with and agree to, and that's most people are comfortable with the idea that we should have some basic ethical constraints on research. For instance, if we're carrying out research on human subjects, we would limit our experiments such that we would require informed consent. So even people who defend the value-free ideal would say, sure, there might be some like very basic ethical constraints that we think need to be upheld in that research stage, but beyond that, we don't want to let these other kinds of values play a role. Now, what's the rationale for that? Well, it's pretty straightforward, really. I mean, the rationale is that these kinds of values, social and political values, are irrelevant to the matters at hand, right? Irrelevant to, how we should develop our mathematical models or whether data support a hypothesis or not. That's the idea. And so insofar as they're irrelevant, if they do play a role, they might be distorting and biasing and so on. Okay, so far all I'm trying to tell you is that one kind of traditional answer to the question of how non-epistemic values should influence research is reflected in this value-free ideal that says we should try to keep these values out of at least the kind of core activity of science where we're kind of engaged in scientific reasoning. However, increasingly philosophers of science are rejecting this value-free ideal. Some of the books on the right are just a few of the works that have expressed some arguments to this effect. Philosophers are arguing that, on the contrary, non-epistemic values sometimes can appropriately influence choices even in that internal research stage and beyond just these sort of basic ethical constraints on, for instance, human subject research. What I want to do today in my talk is suggest that there's a way of relocating the kinds of value influences that these challengers to the value-free ideal have identified, relocating them in a way that maintains the value-free ideal and I hope is actually useful in practice for scientists. So that's what I'm going to be doing in the rest of the talk. First, I'm going to tell you just a little bit more about these challenges to the value-free ideal, because that's going to show us like what are these value influences that people think ought to play a role or can appropriately play a role in research. And then in the main part of the talk, I'm going to try to show you how we could relocate those value influences to make in a way that's consistent with the value-free ideal. If there's time, I'll talk about some objections and replies. We may run out of time, but I'd be happy to come back to those in the question period if we do run out of time. Okay, so let's talk about the two main challenges as I see it, two recent challenges to the value-free ideal. The first is what we could call the argument from inductive risk. And I'm going to literally try to present it as an argument. Now, this is not an argument that appears in the way that I'm presenting it exactly in the book that you see on the slide here by Heather Douglas. Heather Douglas is one of the main proponents of this argument, but this is my attempt at giving a sort of actual reconstruction of an argument in a way that can fit on one slide. So keep that in mind. All right, the first premise says scientists should try to obtain accurate results. That's what we're aiming for in science. We want to find out how things are. But sometimes scientists face uncertain methodological choices among models or choices among methods. And what we mean by that is choices where it's unclear which of the available options will give the most accurate results. So we want accurate results, but sometimes it's unclear which of the options available to us is actually going to give the most accurate results. Third premise, in those cases where we have this uncertainty about methodological options, if it's also clear that one type of error in results, and you might think of, for instance, type 1 versus type 2 error, if you're thinking about a statistical test, if it's clear that one of those types of errors would have worse consequences than another, then it counts in favor of one of our options, one of our models or methods, if it carries a lower risk of the error with the worst consequences. So we're kind of thinking through how different kinds of error what kind of consequences could ensue if we make certain kinds of error. And we're asking ourselves, if I'm so uncertain about which of the options before me would actually give the most accurate results, can I foresee anything about, whether they risk one type of error more than another? If I can see that, it counts in favor of, I sort of have a reason in favor of options that carry a lower risk of the errors with especially bad consequences. Okay, since there's a lawnmower down the street, I'm going to try to move over to another spot and see if that helps. All right.
By the way, I would just interject that the fact that Wendy's speaking outside is not part of the plan, but is rather the result of her heroic efforts to overcome a number of technical difficulties that came up at the last minute. So thanks for everybody's patience with that.
All right, so next premise. It's just to flag that when we're engaged in that evaluative process that I just described, where we're thinking about how different types of error might, what kind of consequences they might have, in that kind of activity, we're engaged in a kind of non-epistemic value judgment. So estimating how bad the consequences of different types of error would be involves a non-epistemic value judgment. Okay, those are all the premises. Conclusion, it doesn't follow strictly, but hopefully you can see that it's meant to support the conclusion. It's sometimes appropriate for non-epistemic values to influence methodological choices, in particular when we're facing these kinds of uncertain methodological choices. Now that's very abstract, so let me just give you a simple illustration that will hopefully make it a lot more concrete. Let's imagine that we're going to do a study that's monitoring levels of air pollution in a city, because we need to get some information on this in order to inform some city traffic rules. We have a choice. One of the choices we confront in our research is a choice among instruments for monitoring the pollution levels, okay? We could go with instrument A or we could go with instrument B. Now I want to set this up as one of these uncertain methodological choices. So in my example, I'm going to say, let's assume that what we know about instruments A and B is that they have a kind of similar overall reliability. They're both pretty reliable. However, when instrument A when it does make a mistake, it tends to read low. It tends to read a low on pollution relative to the truth. It tends to underestimate. Whereas instrument B, when it does err, it tends to read high. It tends to overestimate. So here's a sort of schematic, sort of imagining this. We've got an uncertain methodological choice, the choice of instrument. We're kind of thinking through our choices. If we choose A, we can see we have a higher risk of underestimating concentrations because when A goes wrong, it tends to underestimate. And if we choose B, we have a higher risk of overestimating the pollution concentrations. Then we can think to ourselves, okay, if those errors were to occur, what would be the consequences? Well, if we underestimate concentrations, we might not restrict traffic enough, we might not mitigate enough, we might end up with more people experiencing the bad health effects of pollution that we're trying to avoid with our rules. If we choose B and we end up overestimating and we make that mistake, we might end up kind of over reducing traffic. Maybe that has some economic impacts on businesses in the city. The inductive risk view says we could think about those two different consequences of error, right? Adverse health effects versus economic effects. And we might decide to choose instrument B because the expected adverse health effects are judged to be worse than the expected economic losses. So this is just meant to be an illustration of how when we're facing an uncertain methodological choice, our judgment about how bad different consequences of error could be might come in to help us kind of resolve our uncertainty one way or another, to choose one of the options before us. Now, if we knew that instrument A was just tremendously more reliable than instrument B, it was just a much better suited instrument, we wouldn't be in this situation in the first place. We might just choose instrument A or instrument B. But we're imagining a case where they have similar reliability overall, but different tendencies for error. Now, at this point, you might be thinking, well, wait a minute, why would I just pick one anyway? Rather than appealing to values, why don't I just choose both instruments? Why don't I just put both of them out there and take the range of readings that they give to reflect my uncertainty about what the levels of pollution are? And you can imagine an analog of that move in lots of other situations where you have an uncertain methodological choice. You might think, well, rather than appealing to values to let me choose one, why don't I try to explore the implications of all the scientifically reasonable options I have? And that way I have a better sense of my uncertainty at the end of the day. Now, my reply, this is sort of a reply that's kind of a hybrid of me and those who would defend the inductive risk view, would be to say that's often a good approach. Yeah, there's nothing wrong with going that option in general, going that route in general, but it's not always feasible in practice, first of all. We may not have enough money to put in place instruments A and B. We may need to choose one. And sometimes it's not going to be what's actually most helpful for the decision makers who are using the results. Sometimes it might be more useful for them to have a single estimate than to have a wide range of estimates. So in my opinion, though, it's in these latter situations where it's infeasible in practice to explore the range of possibilities, or where it's not actually most helpful for the goal, the purpose that you're using the study for. It's in those kinds of situations where I think resolving uncertain methodological choices by appeal to values is most justified. So all I'm trying to do at this point is to say, we have this inductive risk argument. We might want to circumscribe the kinds of cases where we think we apply the argument, but there still seems to be some cases left. And in fact, I think that a context in which this kind of situation arises quite often is this area of practice known as climate services. And many of you may be familiar with this area of practice, right? It involves a wide range of efforts to try to analyze, synthesize, and package existing climate information resources in order to facilitate decision-making. It's a growing activity within climate science, broadly construed, intended to support lots of different sectors: agriculture, water, insurance, energy, lots of sectors. Just as an example, right, someone who's engaged in this kind of area of practice might be asked to do an analysis of future water supply for a region under different greenhouse gas scenarios in order to, say, inform some infrastructure decisions. And on the right's just an example of one of those infrastructure decisions, right? Whether to build a new intake pipe in a particular lake that's supplying water. Now, why do I think that this is a context where the kind of inductive risk argument I just described is often applicable? Well, it's definitely a kind of area of practice where there are many uncertain methodological choices when people are trying to engage in this analysis. And oftentimes they have foreseeable consequences of error. In other words, it's fairly straightforward to see how, say, underestimating the quantity you're investigating might lead to a kind of problem in a decision context, as opposed to underestimating. These uncertain methodological choices include things like, which scenarios to use, which computer models to use, which ways of combining their projections, which analysis methods. There's loads of choices that I think count as these kinds of uncertain methodological choices in this context. If we were to apply the inductive risk view, right, the conclusion we would reach is something like, well, climate service providers should consider which errors in the products that they're developing would be especially bad and factor this in when they're making these uncertain methodological choices. And this is something that I tried to sort of sketch out how this could work in a paper with Greg Lusk in 2019 in the Bulletin of the American Meteorological Society. Now, at first I thought that it was a pretty straightforward case of that it was pretty clear whose values should be used when we were engaging in this kind of activity. And I thought, user values, if you're providing these climate services for a client, it seems like the client's values should be the ones that you use when you're worrying about, which outcome is the bad outcome. But I think when you think about it more, you start to realize it's not quite so simple. And, depending on the particular case, it might be the client's values, it might be public's values. There are lots of interesting questions there. Okay, all I want to say so far is this is one argument for challenging the value-free ideal, the idea that we should use values to manage inductive risk, at least in some kinds of circumstances. And I think climate services is a context where the kind of conditions under which the inductive risk argument gets activated, I think those conditions are often met in this context. Second argument, much briefer, the argument from research aims. Okay, again, I'm going to try to flesh it out in a premise conclusion format, again, kind of informally, but to present it as a genuine argument. The first premise says methodological choices in research should promote achievement of the aims of research while respecting.
Dad wants to tell you.
David, I'm on. You have to stop.
Dad wants to know how you're doing.
Sorry about that. The first premise says methodological choices in research should promote the achievement of the aims of the research. Seems pretty straightforward. Seems uncontroversial. Second, it's often assumed that science's aims are purely epistemic, but in fact, they're often both epistemic and social or practical. Third premise, taking account of how different methodological options serve the social or practical aims of research, that is, taking account those aims, not just the epistemic ones, not just the knowledge-related ones, will sometimes make a difference to the choices that you make when you're thinking about promoting not just the knowledge-related aims, but also the social or practical aims. In these cases, methodological choices are influenced by non-epistemic values, and appropriately so. So it's sometimes appropriate for methodological choices, these are choices internal to research, to be influenced by non-epistemic values. So this is an aims-related argument, and it sort of takes as its starting point the idea that the aims of science are not purely epistemic, at least not in all cases. And it uses that to build a case for allowing non-epistemic value influence. Now, let me just give you again, in very briefly, a couple of illustrations. If we were to sort of take on board this kind of aims argument. So let's imagine we have a study where the aims are scientists are developing a diagnostic test for a virus. Clearly, they want it to be reliable. That's a kind of epistemic aim. But they also want it to be useful in practice for, let's say, screening workers or travelers, right? You could think about a COVID test. So you might imagine them making the following value influence choice. They might choose to pursue an approach to developing that diagnostic test that they think will give very fast results. Even if those results are slightly less reliable, they might choose that approach over one that takes much longer, but is more reliable. So that would be an example where a sort of choice in their sort of research strategy could be influenced by the practical or social aims and values. Here's another example. Suppose a meteorologist is trying to improve the accuracy of forecasts from a weather forecasting model. They might be interested in doing that because they, think it's scientifically good to improve the models, but they also might be doing it because they know that better forecasts will save lives and have economic benefits. Now, let's imagine a value influence choice they might make if they're taking this Ames kind of perspective. When they're faced with a situation where they can't improve predictions on X and Y both, they have to say, I can improve predictions on X or I can do Y, but I can't do both. And improvement on one of those, let's say X, is much more relevant to saving lives and economic benefits, then they might choose to prioritize improved prediction of that quantity X. Okay, so again, here we're supposed to be seeing examples of how non-epistemic values, in this case, it's the value attached to saving lives and reaping economic benefits, is making a difference to choices that are made in the internal workings of science, right? Which kinds of choices are made in model development. All right, so now I want to shift to try to make the proposal that I want to make. This is the most important part, to relocate the value influences that these two arguments, the inductive risk argument and the Ames argument, to try to take the kinds of value influences that they think are appropriate and relocate them. And hopefully, if from the last example I just gave, you might already have a hint at the strategy that I plan to take. So I'm going to give you just again an example that was kind of the inspiration I had for the kind of reframing or relocating that I'm going to propose. So let's consider this example. Let's imagine a scientist adjusting the parameter value in a computer model so that it performs better on X, even if its performance on Y gets worse, because accuracy on X is more important for society. So they're facing a trade-off between X and Y, just like in the example I gave you on the last slide, and they're choosing X, and they're choosing X because X is more important for society, accuracy on X. You might think of, like, say, surface variables in the weather model versus upper air variables, something like that. Now, we might say what's happening here is that social or non-epistemic values are shaping choices internal to research, right? The choice of parameter value. But it seems at least as accurate to say that social values have shaped the epistemic priorities of the research. That is, the choice to prioritize accurate simulation of X, and that the choices made by scientists are responsive to that epistemic priority. So that's kind of another way of interpreting what's happening in the example, is to say, rather than a sort of direct appeal to values, we could think of this as values shaping epistemic priorities, and then scientists trying to achieve those or serve those epistemic priorities. In the latter case, right, scientists don't have to be invoking social values in the internal stages of research. They might just be engaging in a kind of means and reasoning toward the epistemic goal, right? Get accurate simulation of X. So that's the kind of inspiration for the approach that I want to now present in more general terms. So here's step one of my proposal. I want to agree that in the big picture, the Ames people are absolutely right that research efforts often do have both epistemic and social or practical aims. But I also like the idea that Dan Steele has expressed in one of his recent chapters, which tries to suggest that, it's true that science has both of these kinds of aims, but part of what's distinctive about science is that insofar as it promotes the achievement of these social or practical aims, it does so via the achievement of certain kinds of epistemic aims. In other words, yes, there are sort of knowledge-related and practical goals, but the situation is usually that we're seeking the knowledge in the service of the practical goals. So the epistemic aims are sort of pursued in part in support of the social or practical aims. So what I want to do first is just distinguish any broader aims of research that we might have, like saving lives or reaping economic benefits, from what I'm going to call the epistemic purposes of the investigation, which might well be selected in part in light of those broader aims. The thing we're trying to find out might be in part because finding that out is going to help us with our practical goals, but it's nevertheless an epistemic purpose. Now, we could think of these epistemic purposes in very simple terms. So for instance, we could say the epistemic purpose of the study is to determine how much summer rainfall would change in this region under this greenhouse gas scenario. We could do that. But what I want to do is suggest we should think of the purposes as having a much richer, or what I'll call enhanced form. And this is going to be the key to that value relocation activity. Okay, so step 2, let's have this kind of richer idea of the epistemic purpose of a study, where it encompasses not just epistemic goals of the study, like the one we just saw to determine how rainfall will change, but also any other epistemic desiderata or preferences for the study or its results. Now, some prime candidates for these additional desiderata or preferences are things like inductive risk preferences. So for instance, we might say, part of my enhanced epistemic purpose is going to be that I want to risk type 2 error before type 1 error, right? So I'm building that in as part of my epistemic purpose. So I have some goals. I want to accurately answer certain questions, or I want to improve my model performance on some variable. I might have various epistemic goals. Yes, that's part of my epistemic purpose. But I can also have some other dimensions to the purpose. One is the inductive risk preferences. Another thing I might have is some prioritization preferences, but these are epistemic priorities, okay? So I might say, I want to prioritize accuracy on variable X over accuracy on variable Y if I can't have both, okay? I might also have something that we might call a form of conclusion preference. I might prefer, for instance, that if the information available doesn't allow for justified probability statements about what's going to happen, then I would prefer it if the results were expressed by, putting the result in one of 5 different categories, which happens to be meaningful, say, for my decision. But all of these are meant to be sort of, epistemic features of the study or its results. And the list could go on. These are just ones that I think are prime candidates, and hopefully you can see how they relate back to the arguments that we were just talking about in the last section of the talk. So an enhanced epistemic purpose might be chosen in part in light of non-epistemic values and goals, absolutely, but it's meant to be something that is referring only to epistemic features of the study and its results. So inductive risk preferences, prioritization preferences, this has to do with what we're trying to find out and how we're going to find it out. Sometimes I refer to it as the kind of an epistemic projection of the broader research aims. It's almost like if we took the richer set of aims and projected it down just to sort of the dimension of the epistemic dimension, what would we get out of it? In the same way that you imagine, kind of analogous to projecting a kind of 3D, geometric shape into a 2D space. All right, so that's step 2. Have this idea of enhanced epistemic purposes. Step 3, now we just say, look, research can just pursue these epistemic purposes. So choices made by scientists in the course of research should be directed at achieving the enhanced epistemic purpose of the investigation, and we'll add this, right, while respecting any ethical or pragmatic constraints. So there might be some pragmatic constraints, like we want you to find the stuff out, but you only have 6 months to do it. So add that in when we're trying to think about what the scientist's job is. So step 3 says the scientist's job is to pursue the enhanced epistemic purposes subject to any ethical or pragmatic constraints that are in operation. The thing I hope you can see without me spelling it out right now is that the choices that scientists will be led to make on this picture are going to be very much like the ones we just talked about in the last section. They can still manage inductive risk in various ways. They can still prioritize accuracy on X over Y. They can make all of the same choices that I was suggesting in the last section, but the choices now are a matter of means and reasoning, right? In pursuit of the epistemic goals, desiderata, and preferences that make up this enhanced epistemic purpose. They don't involve any direct recourse to non-epistemic values in the internal workings of science. So if we go back to this picture that I showed you before, the challenges to the value-free ideal, we're saying, hey, there's room for appropriate non-epistemic value influence here. And what I'm trying to do with my enhanced epistemic purposes is say, actually, we can kind of front load those influences. We can shift them over here and think of this pre-research stage as involving choosing topics, questions, and epistemic purposes in this enhanced kind of way. All right. Now there's one more step to the proposal, and that's sort of saying something about when value influence is inappropriate, which is something that comes up in any of these proposals that call for like allowing non-epistemic value influence. There's always a question about, even if there's some space for appropriate influence, when does it become inappropriate? So on the picture I'm suggesting so far, here's the first and most obvious answer. It's inappropriate, this value influence is inappropriate when it's shaping methodological choices directly in the internal stages of research, rather than shaping the specification of these epistemic purposes. Now there are various ways of finessing that if that doesn't sound quite right to you. But so my first attempt is going to be when methodological choices in the internal stage of research are made by direct appeal to non-epistemic values rather than in pursuit of an epistemic purpose. So the sort of hard reading of the proposal I'm making is to say, you have to put the value influence in if there's going to be any, in the specification of those enhanced epistemic purposes. Leave it out of that central stage. Second answer, value influence will also be inappropriate on the view I'm advocating when the epistemic purposes of the study are sort of the wrong sort. So it's not quite as simple as I just said. I'm also going to put some constraints on how the influence can play out in that first step of setting the epistemic purposes. So if you choose an epistemic purpose that contravenes basic epistemic standards for research, I'm going to say that's inappropriate. I'm going to say what you're doing is just not really scientific. So let me give you a couple of examples. If you say, I have the following inductive risk preference. It's one where I set a standard for rejecting a null hypothesis such that rejection is virtually guaranteed even when the null is true. That's not going to be okay. Likewise, if you say, here's the epistemic goal of my study. I want to increase belief among members of the public that a particular hypothesis is true, regardless of whether it's in fact true. You might say that is an epistemic aim, but it's an illegitimate epistemic aim from the perspective of science as an activity that has a kind of commitment to certain kinds of epistemic goods like truth, knowledge, and understanding. Okay. And third, I think that my view leaves room for arguing that non-epistemic value influence can be inappropriate when the values are just bad values. So I'm not going to try to give conditions for when that would be, but examples would be like when the values that you're appealing to, when you're choosing your epistemic purposes are racist, sexist, and so on, right? So I'm saying here are three different ways that we might still argue that value influence, non-epistemic value influence would be inappropriate on the kind of view that I'm advocating. There's room for all three of these inappropriate value influences. Okay, I can see that we're just about out of time, so I'm going to finish up this section and then I'll be ready to wrap up. What I'd like to do in the time left is just give you an illustration with one, it's still a bit of a toy example, but to try to show how the proposal I'm making would sort of work in an example. And so the example I'm going to talk about is one that we're imagining a climate scientist who's investigating future heat events. So maybe a climate scientist is asked to provide information to some regional planners who are facing some climate sensitive decisions. Again, the toy example, so just run with me. If you're a regional planner, I apologize. We're going to imagine that the density of future development that the planners are going to allow in their region is going to depend on some climate-related variables, in particular, whether a lot more hot days and heat waves are expected. So they might think they're going to limit, for instance, the density of development if they're going to be experiencing a lot more heat waves and very hot days in the future because, for instance, there might not be enough ways for people to cool themselves. They might not have enough energy to supply for cooling, whatever. So let's imagine in my example that in consultation with the regional planners, it's agreed that the climate scientist is going to investigate future changes in summer temperatures in the region out to 2070 under a moderate greenhouse gas emission scenario, like let's say RCP 6.0. And the planners indicate that they need the information in 6 months and can provide up to $100,000. So those are the kind of pragmatic constraints on the research task. All right. So now let's imagine what the enhanced epistemic purpose for the investigation might be like. And as you'll see, I say, we're imagining that this is formulated in consultation with the regional planners. It's not that the scientist just invents it on her own, but it might include the following elements. Maybe it has these epistemic goals. Please accurately answer for us, how would the frequency of very hot days and heat waves change in the region under this scenario? And also, please accurately answer for us how much more or less often the region would experience nighttime low temperatures above a specified threshold for several nights in a row, because this turns out to be really bad for people cooling themselves, right? People die more when they can't cool down at night. Okay, so these are the questions that the regional planners would like answered. They might also express some inductive risk preferences, right? They might say, you know, if you face an uncertain methodological choice, we'd rather that you risk overestimating the frequency of heat events rather than underestimating, because we're really concerned about heat deaths. We want to avoid making choices that set us up for lots more heat deaths. Maybe they express some prioritization preferences. Maybe they say, epistemic goal 2, the one about nighttime temperatures, is really our highest priority, because that's most relevant to our heat death concern. And maybe they even express some form of conclusion preference. Maybe they say, look, if you can't give us precise changes in the frequencies, because we know that probably can't be justified scientifically, then it would be helpful for us if you categorize things in the following way. And they give you some categories, like the increase in frequency will be less than 25% or 25 to 75, and so on. Maybe that feeds into certain choices they're going to make. Okay, so we might imagine that their enhanced epistemic purpose looks something like this. Now, on the proposal I'm recommending, the climate scientist's job is to design and carry out an investigation that achieves that enhanced epistemic purpose within the timing and budget constraints that they're facing. So let's, again, just to wrap up, imagine like what might be some of the choices that they make that are responsive to those that enhanced epistemic purpose. Well, for starters, just thinking about the pragmatic constraints, they're clearly not going to build a new regional climate model from scratch, right? They don't have enough time or enough money. So they're going to use existing models, but now we're going to run into an uncertain methodological choice. Suppose there are several existing regional models that are thought to be of comparable scientific quality. Given the inductive risk preferences for the study, maybe the scientist chooses 2 of those models that she thinks will give middle and upper end projected changes in the frequency of hot days and nights, because remember they said we'd rather you overestimated than underestimated. That would be a worse error if you underestimated. Given the prioritization preferences, the scientist might choose to invest some of her time adjusting one of the models in ways that she believes will improve the accuracy of its simulations of nighttime temperatures, because that was really what they thought was most important. So she might put her efforts in that direction. All right, some advantages of the approach I've made that I'm offering here. First of all, I think it promotes transparency about value influence right from the start, right? If you're thinking that the task when you're taking on a study is to think about these enhanced epistemic purposes, then hopefully you end up specifying any inductive risk preferences and so on right up front. I also think it has the advantage of limiting modes of value influence via the setting of these epistemic goals and preferences. And I think in that sense, it has more guidance than some of the Ames approaches that seem kind of open-ended about how much value influence can happen when you're pursuing social aims. And really, the third advantage is the one that got me thinking about this in the first place. I feel like this is maybe a more useful and maybe more comfortable way of thinking about it in practice. Doesn't sound quite as radical, because the idea of enhanced epistemic purposes, first of all, can help scientists take account of values in a structured way rather than just saying like, hey, there are some ways in which it can be appropriate for non-epistemic values to influence choices in research. In this way, we say, no, here are some dimensions: inductive risk preferences, prioritization preferences. Think about, what your choices should be there. So it adds some structure, but also leaves the scientist's job to be one of pursuing epistemic purposes, not anything else in the end. Okay, I'm going to skip over my objections and replies. As I said, I'm happy to talk about the many objections that you might raise in the question period. And I'll just wrap up to recap here with one slide. right? Philosophers of science increasingly argue that non-epistemic value influence can be appropriate even in the internal stages of research, at least under some conditions. I think that those conditions are often met in climate research, especially like climate services. But what I've tried to suggest today is an alternative, hopefully less radical framing of the value influence that these challengers to the value-free ideal are calling for. So my proposal is that we have non-epistemic values informing the selection of these enhanced epistemic purposes. This epistemic projection approach, as I call it, is consistent with the value-free ideal. It promotes transparency about value influence. It clarifies the limits of appropriate value influence and hopefully is more comfortable and useful for practicing scientists. And that's all. Thanks very much.
Thank you, Wendy. Yeah, we have about 13 minutes for questions, and I have a couple of hands already. So I'm going to call on Yafeng.
Hi, thank you so much for the presentation. I wanted to ask a question about the thing that you said about the last, making practicing scientists feel more comfortable. I'm just wondering, does that suggest a kind of division of labor that perhaps somebody else is supposed to do the job of basically translating the non-epistemic values into enhanced epistemic goals, and then the scientists do? Is that kind of the picture, or am I misunderstanding? Thank you.
Thank you very much for your question. I think that's roughly right. I mean, I would think that it would be the scientists sort of in consultation or along with perhaps someone else who might formulate the enhanced epistemic purpose. And then the reason it's supposed to make the scientists more comfortable, or at least I somehow idealistically hope it would, is that once that's done, then the job of the research task is just geared toward fulfilling the epistemic purposes that have been specified. Now, it's possible that for some, kinds of investigations, there really aren't going to be any salient inductive risk preferences or any salient prioritization preferences. It's not like every single time someone does a study, there needs to be a user and some consultation. But I think that in some of the cases where it's most plausible that things like the inductive risk argument get activated, then there might well be people beyond just scientists whose input is going to shape what those enhanced epistemic purposes should look like. So there may be some division of labor.
All right, I'm calling on another hand from Michiru, and then afterwards I have Samuel and also a chat question from David.
Thank you. This was great. So my question is about this concept of inductive risk preference, because it's tightly connected to decision theory and but in particular expected utility theory and stuff. But when it comes to this decision making, it's very normative, right? And then there's a lot of debates. I think, for example, in Eric Winsberg's recent book about climate science, he kind of takes issue with economists, saying, "Hey, you guys think that you're doing science, but actually what you're doing is kind of ethics." And I don't exactly know what he means by that, because he doesn't really disagree with the whole use of discounting models, but he somehow doesn't like the use of particular numbers in there. But you can also dispute the use of a particular decision-making framework as such. Like, let's say expected utility theory is not normatively valid. How can you deal with this type of issues? Because it seems that you assume that there's one right way of thinking about the risks, and that's contested.
Good. I don't think that the inductive risk argument itself or the inductive risk view has to presume any particular decision theory, but I do think that what you might be raising is that if you're going to apply the sort of inductive risk like strategy or management of inductive risk, there's this presumption that one kind of error is worse than another. And it may be that for some groups of people, one kind of error is worse, and for other groups, another kind of error is worse. And so there might be sort of conflicting value kind of evaluations of the the outcomes. I'm not sure if that's exactly what was motivating your question, but if it is, I think that that's just a challenge that the inductive risk has to deal with. If it might complicate things more, but I think the idea is that, at some point there might be opportunities to manage inductive risk, to push the balance of error in one direction, the risk of error in one direction or another. And if there is a clear preference on avoiding one of those errors, that's the kind of situation in which the argument gets activated. So I'm not sure if that really addresses your question, but I'd be happy to talk with you more later or by email if you want to discuss it further.
Yes, thank you. Thank you.
So I'm going to read a question from the chat, and I'm also going to piggyback on it a little bit by expanding by a thought that I was wondering about. So the question is, what do you think ought to happen when researchers cannot fully specify the epistemic purposes before they get to the internal stages? And I would just add to that, is that what you have in mind for the distinction between direct and indirect influence of non-epistemic values? Is it a question of at what stage they're articulated and sort of made public?
Good. I think I'm still thinking about this, but my initial answer is it doesn't so much matter like temporally whether it happens before, or you could be in the middle. I mean, in practice, right, in real research, right, you're halfway through and you realize, oh, you need to go back and rethink things. And so I mean, certainly that linear picture is a complete, idealization, and there needs to be room for those feedbacks. What I think is important for my proposal is that the way you think about the value influence is not that it just like you make a choice because of some value influence, but rather you want to always have that intervening layer of an epistemic preference. So you somehow have to link whatever the value of interest is to some kind of epistemic preference. Because, and then it's sort of hopefully made visible, and you can ask yourself, like, is this a kind of epistemic preference that's appropriate? Like, does it contravene any basic standards of research? So I think, so it's not so much about temporality as about ensuring that the value influence operates via the specification of an epistemic preference or desiderata, which can then be sort of scrutinized. It kind of is it's sort of two objections in one coming up here. One is like, yeah, what happens if you're halfway through and you have this realization? And secondly, objection, isn't this kind of just a kind of cheap relabeling of what's going on? And I think, there's a sense in which it is a kind of relabeling. I mean, I'm calling it a reframing, a relocating, but I think that like the fact that it can be done is important to recognize. And then that alone, I think that helps to, for me anyway, helps to take out some of the radical soundingness of the let your values influence the internal workings of research. Like, no, once you kind of understand that the way to think about that is it's sort of equivalent to specifying these epistemic preferences, then it's somehow less of a problem, in my opinion. So, or less alarming, less vague and alarming. Yeah.
Thanks. So I've got a hand now from Samuel.
Hi, Wendy. Sam Fletcher here. So I originally had the question that we just discussed, but I had a follow-up question actually, based on your answer and your suggestion that somehow this makes the idea of the influence of non-epistemic values seem less radical to practicing scientists. I was hoping you could expand on why you think it does that. And I wonder whether or not you think that it's related to the kind of Mertonian value of universalism in science, the idea that part of scientific culture is the idea that the products of the science are independent of a quite wide range of factors, which are particular to individual groups and people and cultures and so on and so forth. if that's right, then I take it that like the idea is that this shows that somehow the practices of science are not actually internally inconsistent with its values. But does that seem like it's the reason why the proposal might be helpful or amenable or welcomed by scientists, or did you have another idea in mind?
Good, thanks, Sam. I actually didn't think of it as being related to things like the Mertonian norm of universalism. I was thinking of it in a much more kind of maybe mundane sense of if you try to pursue the kind of framing of things that I'm suggesting, then you preserve the idea that the job of the scientist in research is to pursue epistemic desiderata, epistemic goals, preferences, and desiderata, right? And in that sense, it might be more comfortable. It's like it's still, I mean, it's weird because as I'm suggesting, you know, I think many, if not all of the same choices get warranted on the picture that I'm suggesting, but it's about how we understand what is happening in the research stage itself that I think might be a little bit more comfortable, if that makes sense.
Yeah, oh, sorry, Casey, I didn't know if you. Okay, I was just going to say, I think I agree with you. Maybe another way of rephrasing the question is like, why should someone get so anxious about like things besides epistemic values? And the thought would be something like epistemic values are precisely the universalist values or something like that. And all the other things are the things which are not universalist. You know, that's a rough characterization, right? And that's why I connected it to that Mertonian norm.
Yeah, that's an interesting suggestion. And I think that might, you know, I think that it may be that the discomfort, another explanation of the discomfort is just more straightforward, like this is going to mean value, this is going to mean bias and distortion and so on. And I mean, these are not unconnected arguments. I'm just saying there are other ways I think of also thinking about the source of the discomfort, but I like the suggestion you just made as well. Thanks for that.
Cool.
Sorry, I muted. We're nearly at time, but let's try to squeeze in one more. I'm calling on Nancy.
Thanks, Wendy, for the great talk. And we can talk more about this tomorrow. But one of the things that Casey found out when he did an interview of participants in our big SCRIM network was a feeling of discomfort in how to operationalize, and that was a term at least one person gave, of how to operationalize our attention to values in doing decision support science. And what I was hearing when you were talking about it is a way that would sound like operationalizing. Okay, here are the list of things that people have concerns about. How do we now, which one of these can we consider in the epistemic pursuit of science? Which ones, you know, how do we communicate back with our stakeholders in terms of which ones are unrealistic or if there are trade-offs? And so in that respect, I think you might have some reason to think that, in fact, your way of expressing it will be easier for some scientists who have that operationalized desiderata. My worry is that I'm not sure there will be people other than the scientists who can work closely enough with decision makers or the stakeholders to get the kind of list you're hoping for, because that's a very sophisticated list. And even many decision makers and stakeholders won't have that kind of sophistication themselves.
Thanks, Nancy. Yeah, I do think of things like, you know, B, C, and D here as a kind of operationalization of like, you know, like trying to think for yourself, what are some ways in which non-epistemic values might shape epistemic preferences. These are like the kinds of epistemic preferences that I think some of the most plausible ones to be, shaped by non-epistemic considerations. And one of the worries I have is that that someone might say, well, you're never going to be able to come up with a list that will sufficiently capture all the relevant categories. And that might be right. Originally, when I developed this proposal, I was thinking that B, C, and D would be exhaustive and that would be all you'd need. And then I think I realized, well, maybe not. We want to leave it open to other kinds of desiderata or preferences. So now I'm making it more flexible, but I do feel like these are kinds that surface a lot. And the way that it might speak to your worry about, how are we going to have the right people to sort of flesh these things out in the right way that captures the relevant non-epistemic concerns. I mean, we could try to imagine really simple questions that get a list of simple questions that are whose answers are meant to give us the information we need about these kinds of preferences. So would you rather underestimate the variable you're interested in or overestimate if you had to pick one? Is anything you're asking me to find out for you of more importance to you than others? Would you rather have information on X versus Y if you had to choose? I mean, I'm hopeful that there might be a way of sort of fleshing these things out so that it could be operationally useful and not overwhelming, maybe not using, this terminology that I've used, but as a kind of helpful structure for thinking about how we could be more attentive to the sort of non-epistemic aims of research, but in a way that's appropriate and doesn't compromise the integrity of the science or anything like that. So I'm trying to be optimistic.
Thanks, Wendy and Nancy. We are a bit over time, so I have to wrap up right now. This is the last webinar of the semester. And there may be some more next year, but it's in the planning stages right now. So Wendy, thanks again. Thanks so much for being here.
Thanks a lot for having me.
Bye, everyone.